Welcome to the Java crash course for 1113 final exam. Yeah, I'll present it. Okay, so this is what we're going to go over today. So we have interfaces first, and we're going to go into anonymous classes and lambdas, and then we'll cover generics and wildcards as well. So this was mostly just from the form responses that for the form we put out, and then after that we're gonna have lunch in between. And we'll look at some past exam questions and work through them together. Yeah, so we can just get started with interfaces then. So yeah, interface is basically a contract that defines like a list of methods, and then every class that implements an interface is going to have to define the method in the interface. So for example, if I have an interface called shape and I have a method in there called area, every class that implements this interface, the shape interface, needs to define the area method. So they also added default methods in Java 8, where usually an interface method doesn't have a definition, and we just define it when we implement it. We can add default methods now in Java 8, and this just allows us to define default behaviors for methods. So I'm going to just demo implementing a shape interface now. So yeah, this is my shape interface. We've got this method here, which we need to define when we implement it, and then this default method. Just going to say default. So I'm going to create a square. So public class square will implement the shape, and I just need to write the area method. So I'm just going to set up some variables first. So public int. Yep. I'm just going to do a side length, public side int length, and then I'll do a constructor. I'll make it a double, actually. All right. And now the constructor setup. And then if I try to compile it now, if I open a terminal. Okay, if I try to compile it now, I do. Yeah, so it'll tell me that I don't have the abstract method area implemented, which I defined back in the shape interface. So now I actually have to implement that method. So I'll just do public area. I can just return length squared. So times that. Yeah, then we can make another class as well to show that multiple classes can implement the same interface. So public cool implements, okay. And then the public static. A static variable for pi. I set that 3.14. Make the constructor and yeah, it's going to define the array method as well. And for the circle, we can make the return value different or the method different. So we'll do return that. Yeah. And then this is the demo class I prepared earlier. Just as the main function that is going to use the classes that I just made. And it should run if I coded everything correctly. So just compile everything. Oh no. I spelled circle wrong. Oh, damn. Okay. Yeah.
Missed the return type as well.
You're right. Yeah, so let's compile everything then. What other thing do I have? Square. Oh, I didn't save the square. I didn't save. Okay. Okay, so into the demo class compilers, I'm just gonna run it. Yeah, and when I run this, it should print the greeting, which is I am a shape. And the square area is going to be 16, hopefully. And then the circle area should be pi times 4, which is like 12 point something, I think. And yeah, we pretty much get what we expect. So yeah, those are the interfaces. Are there any questions about that? Okay, and we'll move on then to anonymous classes. So anonymous classes are just classes that we don't give names because we pretty much just construct them just to use for like an instance. So basically you use them when you need to define like a small one-off class for a specific purpose without the need to create a separate name class. So let's say if I want to represent this shape in my program for some reason, and I can't be bothered writing a whole class for an ink blot. I'm just going to create an anonymous class by doing this. So in this case, I haven't actually defined like a class name. I've just created a variable inkblot, which uses this class that implements the shape interface, but there's no name for that class. But all we need to know is that the area method of this class is always going to return that area, which is 14.5. And lambdas are pretty similar as well. But if we go back to anonymous classes, I could have defined more methods under here. In lambdas, these are only used for interfaces that only declare one abstract method. So they can only have one method that's non-default. So the way we do what we did before with a lambda is we declare the variable the same, and then we just do brackets, and then whatever's inside the brackets is the parameters. Remember for the area method, we didn't have any parameters, which is why this bracket is empty. And there's just an arrow pointing to the method body. So yeah, so the method body is to return that area, 14.5. So we're going to demo using lambdas now, just with a binary operator interface. I'll go back to tab. Yeah, we're going to binary operators. And if you look at this interface, I only define one method, which takes 2 integer arguments. And I've already created the one for multiply, the lambda for multiply, which is I write the list of arguments, so x and y, and then I define what the behavior of that method is. So whenever I call this object's apply method, it's just going to do whatever is inside the lambda expression. So yeah, we'll do one for adding now. So this one should be pretty much the same thing. If I create a lambda expression for adding x and y. Oh. I just have to return x plus y. Yeah, and then if I print that result, add both. If we use the numbers 2 and 3 again, it should give me 5. Yeah, and then we'll do one as well for like a power, because this is just to show that you can put multiple lines in your lambda expression. So we'll let this function just do x to the power of y. And to do that, we can just use you can just do a for loop unless we import the math package. So we'll just do result. Oh. Equals x, and then should be. You can write like a for loop and everything inside the lambda. So just do result divided by x, and then we just return that. And result. Yeah, so if I print out a use of this function, right, that should give me like 2 cubed is 8, pretty sure. And then it should give me 6. And this will give me 5, hopefully. So just compile and run. Oh, did I forget a semicolon? True, I did. Oh. Yeah, and those are my results. So 6, 5, and 8. So yeah, I've just used a lambda expression here, and we just define the method. And we know that this xy method always refers to the apply one, because we're only allowed to have one of those inside the interface. So it default points to this method. Yeah, so that was lambdas. We'll go into generics now. So yeah, so everything before was like relating to interfaces. Now we're on a new topic with generics. Generics allow us to parameterize types in a class, and we define those type parameters with angular brackets. So I'm going to demo a generic container real quick. So here we have a main. I wrote the main method like beforehand, and basically we just need to be able to initialize the container as any type, and then there's a get method and a set method. So we'll do the constructor then. So container T. Yeah, and in this case, T is our generic, and T just refers to any class that we define when we create the instance. So start element equals element. That should be fine. And then so So we'll do a set method. The public void set, and it should take a t element as a parameter, so that it will just set the element as the new element. And then a get method that just returns the element. So all right. Yeah, and then so in our main class, we initialize a container and we use the string as our parameter class. And basically, whenever we initialize this class, it's going to create basically what we've written here, but it's just going to like command F and then just replace all the T's with string if we do contain a string. Yeah, so I'm creating a container that just stores a string inside, and we let it be Java. And I realized I forgot to change my variable name when I was editing. So I'm gonna do this. My code real quick. Yep. And then we use the set method to change it into our crash course, and then we print that as well when we use the get method. And we can also use the same class now to store an integer if we initialize it with an integer parameter. And yeah, I'll just like run this, and it should just print Java crash course 2023. Oh. That should be an empty. Should be. Yeah.
Like an example.
Right.
What's the value?
Okay. Why did I print that twice? Oh, it's because I didn't change. Okay, so yeah, that should be in container, and then it should just print everything. Yeah, so we'll move on. So here's a generic class that you may already be familiar with. It's the array list one, and you've probably used it before. So that E is the parameter. And yeah, so in this first like line, I create an array list of integers or an array list of strings. And it just saves us the trouble of needing to use a different class for every type. We want like, yeah, so we just use an array list and we can create that for any type versus just creating different one all the time. So next we have wildcards. And yeah, so these are used with generics to represent an unknown type, a range of possible types. And there's basically 3 wildcards should be concerned with. So first one is unbounded wildcard, and these basically just represent an unknown type. So you can use it to accept any argument. For example, if I have like a print list method, and it takes in any list, and the list can be of any type. And it will always just print whatever element is in the list, or all the elements in the list. Yeah, and the next one's an upper bounded wildcard. This one just uses the extends keyword to upper bound the generic. So if I have this question mark extends number, that just means that whatever list object I put in here, the class parameter of the list has to be a subclass of number. So yeah, so this one just like sums up the list, and since we upper bound the wildcard to always extend number, we're allowed to use the plus operator on it because we know that all numbers can be added to each other. Oh, sorry. And next one is the lower bound wildcard. Now this is usually used for methods where we are adding to a list. So yeah, we use the super method, we use the super keyword to lower bound our constraints. So for example, in here, list super integer just means that this list has to the parameter class of this list has to be some superclass of integer. So it could be like a number list. And we just add an integer to that list. Yeah, so the point of lower bounding here is to make sure that we can actually add integers to it. So for example, if we upper bound a number before, we could have passed in like a list of doubles. Or we could have passed in, yeah, a list of doubles. I guess you could add an integer to a list of doubles, but let's say it was the other way around. Let's say this was an add double method, and we use the extends number instead of a super double. If we try to add a double to a list of integers, it wouldn't do what we want. So this just makes sure that we have some like list that can actually accept the type that we're putting in. Okay, so we've gone up to practice questions now. Yeah, I guess we can take a break then. For like Q&A.